Alright, hello, this is the screencast for the 5.2 notes, which is synthetic. So what I did was I remade the notes for this section, but otherwise the rest of the notes packet will be fine. So this is just me screencasting since I missed the class on Friday. This is for the 4 people who also missed the class on Friday. So synthetic division is a shortcut method to divide polynomials. Right, so what this means, so remember polynomials, the exponents are 0 or greater. Integer numbers. Integers. So what this means is you have to have something like x squared plus 5x plus like 2. That is a polynomial because all of the exponents are 0 or greater, right? Here, this exponent's 2. Technically, this is an exponent of 1. And if you just have a number, I mean, that's just times x to the 0, because x to the 0 is 1, 2 times 1 is just 2, right? So this is a polynomial. All right, this is used only in the special case, only if you're dividing by linear factors. So linear factor is when you're dividing by, let's say, x minus 1. This has to be a line. You can't be dividing by something squared, right? You cannot be dividing by x squared plus 2x or whatever, because this is not a linear term. You only can use synthetic if you're dividing by a line. Okay, so let's go through. So look at example 1. Go ahead, see if any of these can be use synthetic to divide any of them. Pause the video. Okay, so this first one, this is not linear, so you cannot use synthetic division. This is a line, right? X plus 5 is a line. We're dividing by a line, so you can use synthetic, right? Synthetic, you only can use if you're dividing by a line. This is not a line, right? The x squared makes it a quadratic term. And then this is a line. Even though it's 3x minus 2, there's a number in front of the x, it still is linear. So how do you use synthetic division? All right, so we have this x cubed minus 3x squared minus 2x plus 4 term, and we're divided by x minus 1. So the first thing you do is set up the synthetic division, right? So you draw this little, not really, it's kind of like an L shape, it's just, you know, the bottom of the L is going out further. Check to make sure all exponents are in present and decreasing order. So 3, 2, this is to the first power, this is 0, right? So we're decreasing and they all are present. Bring down the leading coefficient to the bottom row. So first, I need to make sure I fully set it up. So whatever I'm dividing by, this is called the divisor. I set it equal to 0, and you solve to get what x is equal to. All right, this number is what you put over here. So I put -1 there. Then you bring down the leading coefficient to the bottom row. So this coefficient right here is 1. The next coefficient is -3. The next coefficient is -2. And the last coefficient is 4. All right, multiply, the first step is bring down the leading coefficient to the bottom row. So you bring it down, all right? So all this part I wrote in green was setting up the synthetic division. So I bring it down. Then multiply the value just written on the bottom row by the outside number. So these two, you're going to multiply. 1 times 1 is 1. Then add the column created in step 3. So you add these, -3 plus 1 is -2. Then you're going to multiply -1 times -2. This is going to be 2. Then repeat, right? So we have to repeat this till we're done. Add this together, right? So we're going to add, this is 0. Then, you guessed it, we're going to multiply 0 times -1. Well, it's just going to be 0. Add them, and you get 4. Okay, so you write out the answer. So the last one, this is the reason I drew the line, this is always your remainder. So remember when we did long division, we had a remainder, we had something left over. This is what is left over. So we started with an x to the 3rd term, so we start with 1 down. All right, so 3 minus 1 is 2. So we'll start with an x squared term, and these give us our coefficients. All right, minus 2x, and then we have plus 0, right? There's no constant, and then plus 4 over, remember, we were dividing by x plus 1. So this is the first answer. All right, so you go ahead, try example 3, and I will write it out. So I have x minus 1, so if I set that equal to 0, I see I'm going to have 1 as my number over here. Write down the coefficients in leading order. Let's see, 3, 2, 1, 0. All right, so I have all of my exponents. So I just write out my coefficients, 2, -5, +5, and -2. Bring down the first number. Why is this so low? I should bring that up. Perfect. Bring down the first number. Then you multiply these two, right? 1 times 2 is 2. You add this column, right? So add that column, -5 plus 2 is -3. Then multiply, 1 times -3 is -3. Add this column, we get 2. Multiply 1 and 2, we get 2. And then you add them and we get 0. So I have no remainder, which means it goes evenly. So x minus 1 has to be a factor. So I start with an x to the third. So I was dividing an x to the third term, so I start with an x squared. And remember, these are the coefficients. Minus 3x plus 2. And there's no remainder, so this is it. Now, what if you are missing an exponent? So I have 4, 3, 2, 1, and then none, right? I'm missing an x squared term. So notice since it's missing, you have to insert a 0 into its place. So I write down all the coefficients. I have 1, 4. I have to put in a 0 since I'm missing. This is my x squared term. I have a 0 as the coefficient because it's not there. Anything times 0 is 0. -12 and -9. All right, I set the thing I'm dividing, x plus 3 equal to 0, to see what number I put on the outside. So since it's -3, I put it here. Bring down the first number. Multiply these two together. Add these two. Multiply -3 and 1. Add these two together. Multiply those two together. Add -12 and 9, so it's -3, and then multiply -3 times -3 is 9, which is 0. Once again, guess what? No remainder, because it goes evenly. And if you did long division, you would get this exact same answer. It's just synthetic is so much faster. Okay, start with an x to the fourth term. So my first is going to be 1 less, which is x to the third, 1 less an exponent. And then it just goes down. Perfect. So you can pause this video anytime to try this, but I'm just going to keep going through. So use synthetic division to divide. All right, let's see. 4, 3, once again, I'm missing the squared term. There's no b squared. Otherwise, it would be in here, right? There's none, so hence the coefficient is 0. You have to leave a space for it. So I have 6, -8, 0, 12, and -14. And if I set b minus 2 equal to 0, I see the number I'm going to be putting over here is 2. Bring down the 6, multiply 2 and 6, which is 12. Add -8 plus 12 is 4. Multiply the 2 and the 4, so you get 8. Add, you get 8. 2 times 8 is 16. Add this, we get 28. Multiply 2 and 8. We get 56. 56, and then if you add those, you get 42. Okay, so notice the quotient starts with a b to the fourth term. So, I'm sorry, the dividend starts with a b to the fourth term. So we have to, our quotient, the thing that we end with, has to start with b to the third. 6b to the third plus 4b squared plus 8b plus 28 plus 42 over, well, we were dividing by b minus 2. Perfect. Okay, so now we notice, ooh, we have a number in front of my x. So the first thing to do is divide everything by the number in front of the x that you're dividing by. So since a binomial has a factor of 5, divide both polynomials by 5. So I end up with, well, 10 over 5 is 2x squared. 15 over 5 is 3x. 20 over 5 is 4. And I am dividing by x plus 1, right? Because I'm dividing each of these by 5, right? 5x over 5 plus 5 over 5. It gives me x plus 1. Okay, now that I have that, I can set this term equal to 0. So that's the number that's on the outside, right? Draw my L with my bar. I have 2 to the first and 0. Okay, so I'm good. I'm not missing any exponents, because whatever you start with, let's say we start with an x to the fifth, you need to have a place for the x to the fourth term, you need to have a place for an x to the third term, to the second, to the first, etc., etc. All right, bring down the first number, multiply -1 and 2, -2, add these, get 1, multiply these, get -1, add them, you get 3. So we will have a remainder here. All right, so since I start with a x squared, I'll start with an x to the first, so 2x plus 1 plus 3 over x plus 1. So we put the number that goes here is what we're actually dividing by, and you have to be careful, right? Because for instance, if this bottom part was 3 over x plus a half, we have to simplify it. I can't leave it like that, but we're good for now. So go ahead, pause this video anytime if you want to try these by yourself. I'm also available at Bonus, so you can come and ask, or the Math Center, he's open as well. Okay, so let's use synthetic division to divide this. So first we have to divide everything by 2 because there's a 2 in front of your x. So 2 over 2 is x cubed minus 3 over 2x squared minus x plus 3 over 2. So we're dividing by x minus 3 over 2. So don't be discouraged. All right, this looks hard because you have fractions, but it will all work out, so don't worry about it. All right, we set what we're dividing, our divisor, equal to 0. All right, we see our magic number is going to be 3 over 2. Let's put our exponents. So I have 1 is the exponent in front of our third term, our cubed. Negative 3 over 2 is in front of squared. Negative 1 is in front of x to the first power. And then we have the 3 halves. Bring the first number down. Let's bring the first number down. Multiply 3 halves times 1 is just 3 halves. If you add that, negative 3 halves plus 3 halves, well, that just goes away. Any number times 0 is 0. Add this, negative 1. When you multiply, you get negative 3 over 2, so you get 0. There's no remainder. So that's pretty nice. We start with a cube, so 1 less. We start with a square. There is no x term, right? Because this is our x squared term, this is our x to the first term, and then so it's just x squared minus 1. There is no single x. All right, 2 more examples to go. So once you pause the video, go ahead, try this one out. You already know the first thing we have to do is divide everything by 2. So it leaves us with 4x to the fourth minus 2x squared plus 1/2 x plus 2. All right, all I did was divide each of these by 2, right? So this is secretly a 1 in front of x. And I'm dividing by x plus 1/2. All right, so if I set this portion equal to 0, no surprise, it's literally going to be the opposite sign, but then the same number right here. So negative 1/2. Let's go ahead and write out the coefficients. I have a 4 in front of the fourth. There is no x to the third term, so I have to put a 0 for the placeholder. Negative 2, 1/2, and 2. Bring down the first term. Bring down the first term. Okay, half of 4 is 2, but it's going to be negative because there's a negative right here. So it's negative 2. And if I add these, I get negative 2. Okay, so if I take negative 1/2 times negative 2, the negatives cancel out. Half of 2 is just 1. So this turns into just 1. If you add this, you get negative 1. Well, negative times negative makes this positive, so you add it, you get 1. And then when you multiply, you get negative 1/2. Ooh, 2 minus 1/2 is the same thing as 4 over 2 minus 1 over 2, which is 3 halves. So I have a remainder, and it's a fraction. So this one is probably the hardest we've done so far. Okay, so I start with the fourth, so I subtract 1, and I'll start with an x to the third term. 4x to the third minus 2x squared minus x plus 1 plus 3 over 2. And remember, right, I was dividing by x plus 2, so that's what has to go on the bottom, is x plus 1/2. Since that was what I was dividing by, that's what has to go at the bottom. Okay, so we're not quite done, right? I can't leave this in terms of fractions like this. So I'll rewrite. I have 3 over 2 over x plus 1/2. I need to get rid of the fraction part. So what I'd like to do is multiply by 2. That way this part cancels out. But I can't just willy-nilly multiply by any number. What I can do is multiply by 2 over 2, since this is just 1, right? This is equivalent to multiplying by 1. Keep in mind this is our remainder, and that's why we had to write it over the divisor thing we're dividing by, which is x plus 1/2. So the 2's cancel out on this top part, but when I distribute the 2 across, this is going to be 3 over 2x, and half of 2 is just 1. No surprise, this is the exact same thing. This number is what we started with, right? The 2x plus 1. So to finally write out the answer, I'm just going to copy this part down. Minus 2x squared minus x plus 1 plus, and then this is the portion I'm going to write, 3 over 2x plus 1. So I don't think I'll give you one this hard, but it's good to understand this because if you take trig next year, you're going to have to know how to do this. Okay. We have one more problem left. So I have to just divide everything by what's in front of my variable that I'm dividing. The coefficient in front of the variable in my divisor. Divide everything by 3. So I get 6c squared plus 2c plus 3, and I'm going to be dividing by c minus 2/3. So positive 2/3 is what is going to be on the outside, right? Because if I set c minus 2/3 equal to 0, add 2/3 on both sides, you get c is equal to 2/3, right? So whenever you set equal to 0, the number you get is always the number you put right here. Okay, copy down the coefficients. So I have 6, 2, and 3. Bring down the first coefficient, 6. Okay, so now we have 2/3 times 6. This is going to be 12 over 3, which is just 4. Add, you get 6 again. Well, we know it's 4 because we just did this multiplication. All right, 3 plus 4 is 7, so I have a remainder of 7. So I start with a square, so this is just going to be to the first power, 6c plus 6 plus 7 over, well, this is what we divide by, so that's what I have to put right here. Okay, so this is c minus 2/3. Oh, we can't have that fraction. I don't want a fraction and a fraction. No, so we have to simplify. So I'm going to take this part over here, 7 over c minus 2/3, and to get rid of the 3 on bottom, I'm going to multiply by 3, right? Because that way I can distribute it out, and that gets rid of the fraction right here. All right, that gives me 3c minus 2. But on the top, I also have to multiply by 3. That way, I'm multiplying by 1, because 3 over 3 is the same thing as 1. So this is actually 6c plus 6 plus 21 over 3c minus 2. So this is it, and you may notice that the last two problems are number 8 and 9 from your homework. Hint, hint, if you've followed through the screencast this much, I might as well tell you I did the last two problems were your homework. All right, so I'm pretty sure this is number 9. I'm pretty sure this is number 8 of your homework. You're welcome. Thank you for listening to the screencast. So notice that the thing I end with was my original divisor. The thing I end with was my original divisor. The only special case is up here. Well, wait, I actually started with 5x plus 5, but I mean, because it was 5x minus 5, right, the 5s will cancel out. Then I could just leave it because x plus 1 is not a fraction itself. Okay, well, that's it. Let me know if you have questions. Email me and we'll be good.